What up, everybody? We're going full YouTube today, okay? So first off, don't forget, like the video, subscribe. Don't forget to smash that button. Ho ho! All right, we're at 200 and something subscribers. We get that up to 300. We're gonna get a thank you video, okay? So I'm bored. It's late, so we're gonna do it this way. So go ahead, guys. Take out your lesson 6.1b. We're gonna look at the rational number system, and it's going to be really, really fun. Okay, so first things first, before spring break, we looked at this rational and irrational number system. So we talked about this earlier. We actually, it says sort and write the numbers listed below into the correct categories. If a number belongs to more than one category, write the number down in each one. So before we get to that, I want you to look down a little lower, and it has the definitions of your notes. So we're going to go ahead. These are just going to be up here, and what I want you guys to do is write these down. So we're going to do a few videos. A few, let's see. Check forms. Okay, so we are going to go ahead and look at this really quickly. So natural numbers, if you guys remember, those are the numbers that are found in nature. The first one's 1, so it's like 1, 2, 3, 4, so on and so forth, okay? The second one is whole numbers. So the whole numbers are all the natural numbers, like 1, 2, 3, 4, but it also includes 0. This is what's different, okay? Okay, so then the next one, it says integers. Integers includes the whole sets, the whole numbers, so like 0, 1, 2, 3, 4, and their negative counterpart, like -1, -2, -3, okay? And then the final thing is rational numbers. Rational numbers is any number that can be expressed as a fraction. So it's like P over Q. What all this is saying is any number, so the integers before it, like -1, 0, 1, these are all rational numbers. Any number that can be written as a fraction, like 2/3, or any decimals. So for instance, something that's like 2.7. Now I said any decimals, but I wasn't able to quite finish there. It's any decimal that ends or repeats. These are examples of rational numbers. So a few examples of this is like 2.7, -0.3, 4.3, repeating. All those are examples of numbers that can be written as a fraction. So let's go ahead and explore this really quickly. And what we want to do is sort those numbers on your side. So really quickly, on the right-hand side, you see all those numbers. I want you to sort those. So pause this video, and when you're done pausing it, it should be, we can jump back into this, okay? All right, guys, you should have finished all this. I'm going to reveal the correct answers now. So here we go. We have those natural numbers. It's 45. And this is trying to trick you because the square root of 121 is 11 and the square root of 16 is 4. Okay, so now let's look at these. This includes all the previous ones. So all the previous numbers, but the only difference is this 0. Okay, so now let's go ahead and look at these two sets. And when I have integers, remember integers is everything before it, so 0, 45, 11, and 4, but that's negative counterparts, so like -8, and this square root of 81 is 9, but you have that negative in front of it, so it turns into -9. Now rationals, remember any number that can be written as a fraction, so like this, decimals that repeat, and yeah, so those are all those types of examples. Okay, so what of these numbers have in common? So these numbers that we have that we did not circle, these are what we would call irrational numbers, and we looked at that previous. Irrational numbers are any number that can be, that's a fraction that goes on forever, and it does not repeat, okay? Getting blocked there by that recording, and I don't like it. Okay, so any number that goes on forever and does not repeat. So the most famous one we have here is pi, right here, and the square root of any non-perfect square, okay? So it says define an irrational number. So an irrational number is any number that is a decimal. It's not just it's a decimal, but it's more importantly as a decimal that, here's two parts, it does not end, or, excuse me, I should say, and goes on forever. The other way to figure it out is a square root of a non-perfect square. So really quickly, the most famous version of this is pi. You're going to learn e, but then the square root of, like the square root of 2. You can't take the square root of 2. That would be an irrational number. It's like 1.3 something something something. The square root of 3. Square root of 4, that equals 2. So that is not an irrational number, okay? Oops. Hi, YouTube. This is messing up everything. Julian, I blame you. Okay. See, this needs to go away. That's what's bugging me. I can just teach it like that. Okay, so that looks good. So now, guys, what we can go ahead now is look at the next one. It says circle numbers below that represent an irrational number. So once again, the irrational number, hide it like this. There you go. So an irrational number would look like this. This number repeats and goes on. This number repeats. It's a decimal with a repeating sign, so it is not irrational. This, the square root of 64, is 8. Cool. Now, 0.50813, it does not repeat, and with the dot, dot, dot insinuates that it goes on forever. So right there, we would say that this is an irrational number. 0.378 is a rational number because it ends. Okay. 9.44444 repeating, that it just depends because it says dot, 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 it just continues to go. We don't know if it's repeating or not. Since there's no bar on top of it, we can't assume that all the numbers are 4. So this one's trying to trick you. So this one, we don't know what it is. Okay, so we're just we don't. It doesn't tell us that it's repeating, so we would call that irrational. But I don't even really want to circle it. So let's pretend this has a bar over it, and we'd say, oh yeah, that's a rational number. Now the square root of 20. If you remember this, if you looked at your perfect squares, like the square root of 4, the square root of 9, the square root of 16, the square root of 25, these are perfect squares like 2, 3, 4, 5. The square root of 20 is in between these two values. And since it's not a perfect square, this would be an irrational number. Okay? So how do you know if a decimal number is rational or irrational? So one more time, if it's rational, there's two key points. The first thing is it ends. If it ends, it's like 3.7, 0.4. That is a rational number. The other one, if it goes on forever. So an example of that is like 0.3 repeating. Okay. So now what we are going to do, we're just going to skip those rules really quickly, is we are going to learn how to take a decimal and turn it into a fraction. Okay. So remember, the rule for a rational number is any number that can be written as a fraction. So these are somewhat easy. If we remember the decimal place values, it's the decimal, and the first value is tenths, then the next one is hundredths, thousandths, so on and so forth. So if you looked at this, so all we do is read the number. This is 275. So the numerator is just the number, okay? So it's just the number given. Okay, so this would be 275. And the denominator would be your place value. And your place value is the tenths, hundredths, thousandths. So 275 over, this is my tens, hundredths, thousandths. The greatest place value is the thousandths. So it'd be 275 over 1,000. And then all we do is simplify that. So if I take 275 and divide it by 25, I'd get 11. And if I took 1,000 and divided by 1,000 divided by 25, this would give me 40. And this would be the most simplified. So once you put it in this place value, you still need to simplify it, okay? All right, so then the next one is I have this. I'm going to just move it right on over here. Oops, I can't actually. I'm going to take this point, negative 0.016. So I have negative 1's a whole number, so I'm going to put that out in the front. So we're doing this one right here. And I have 6 hundredths. So it would be negative 1, 6 over 100. So this would reduce then to negative 1 and 3/50. And that's your final answer. Okay? Okay, it's still there. How do we get rid of that? Oh, it's gone. No, it's back. It's gone. Okay. So now let's go ahead and look at this. Now what we're going to do is convert a repeating decimal, 0.5, repeating into a fraction. So I'm going to show you how to do this. The first step is you're always going to set this value. This is the tricky part, so make sure you guys are taking notes. Is x equals 0.5, repeating. Now remember, 0.5 repeating is like 0.55555, and it just goes on forever. And what I need to do is I need to create two equations. The first equation is you need this decimal to come right after the number that repeats. So I need to move this decimal over one spot to the right. Okay? Well, how do you do that? I would need to multiply both sides by 10. This would give me then 10x is equal to 5.5 repeating. Okay? Essentially, I multiplied it by 10 and moved it over here. The second equation you need, and lucky for us, we don't really need to do much here, is you need the decimal that repeats, and then right after the you need the decimal, and right after that, the number that repeats. So you have the decimal, and then the number repeats, so you're all good there. So your second equation is just x equals 0.5 repeating. So what I want you guys to do is we're going to write these notes down. So your first equation, you're going to multiply both sides in order to have the number that repeats then the decimal. So remember, the number that repeats is 5. So it says the number that repeats, then the decimal. So we multiplied both sides by 10 to get this to be 5.5. Remember, this is the number that repeats. The second equation, it's going to be the decimal, then the number that repeats. Now on the easy ones, like this, you didn't have to do anything on that in the green equation because it's already there. So then what we are going to do, so it's kind of like step 1, step 2. Step 3, what we're going to do is subtract both equations. Then solve for x. So for instance, 10x minus x is 9x. And then think about this. If we subtract these, and these go on forever, what is going to subtract when we subtract these equations? Well, I'm going to have just the 5 here, but then the entire decimal is going to be canceled off. So now I have 9x equals 5. So when I divide both sides by 9, I'm going to get x equals 5 over 9. All right, guys. How's the quarantine haircut looking? Comment in the comments below. Okay, so let's go ahead now and look at this. 0.74 is my x, and then what we need to do is remember the first equation, you need the number that repeats, then the decimal. So think about this. What would I need to multiply both sides in order to have the number that repeats, then the decimal? I would have to move it over 2 times. So I'd have to multiply both sides by 100. So my top equation would be 100x is equal to 74.74 repeating. Okay, so it's the number that repeats, then the decimal in that first equation. Second one, as we talked about, it's the decimal, then the number that repeats. So I didn't need to do anything there. And now what we're going to do is we are going to subtract these two equations. So when I subtract these, I'm going to have 99x is equal to 74. Now I'm just going to divide both sides by 99. And hopefully we're starting to see a pattern here, guys. On these easier ones, where it's the decimal and then the number that repeats, all you have to do is put that number under how many spaces it is, okay? So you write the number, put a line, and then put it over 9, basically. So this had 2 decimal spots, put it over 2 9s. Previous one had one number that repeated, and we had 1 9. So if we were to take a guess now on this B part, I have 2.4. I have the decimal, and then I have the 4, so it's just one number. So this would look like I have 2, and then I have 0.4 repeating. Well, remember, if I have 0.4, which is the number that's repeating, that equals my x. And I would want the number first before the decimal, so I'd multiply both sides by 10 to get 4.4 repeating equals 10x. And then this second equation, which I already have, would be just 0.4 repeating equals x. So when I subtract these, I'm going to have 4 equals 9x. When I divide both sides by 9, I get 4 ninths. So I want you to realize that this then is the whole number. I didn't have to do anything with that in the equation because I just need to write the decimal as a fraction. And that would be 2 and 4 ninths. So one more time, it's the decimal, then the number that repeated was just 4. That's just one number that's repeating, so I put it over 1 9. Finally, let's go ahead now and look at this one, and we'll try a few challenging ones then. So when I look at this, guys, if we were to guess what this would look like, we've seen this before, I have the number, and then it's 3 values, so it's just going to be 3 9s. That's my guess right here. So let's see if that's correct. I'm going to have x equals 0.105. I need to have that moved over 3 times, so I need to multiply it by 10, 100, 1,000. So I'm going to multiply both sides by 1,000. So I have 1,000x is equal to 105.105 repeating, okay? So then when I divide, and then on the original equation, I'm just going to have x equals 0.105 repeating. So now when I subtract these, I'm going to have 999x equals, this gets eliminated, 105. I'm going to divide both sides by 999. And there you go. So hopefully now you can see the pattern, okay? So if I looked at this table, we can see the pattern that this is the decimal, then the number that repeats. So 5 over 9. 74 is 2 numbers that repeat, so it would be over 99. This would just be 2 and 4 over 9. And this one would be 105 over 999. Okay, now what we're going to do is look at the more challenging ones. So the easier ones when it was just the decimal and then the number that repeated, okay? If you notice on here, the entire number does not repeat. It is just the 6. So this is when the rules are going to come in a little bit more handy. So I have 0.16 with just the 6 repeating. So basically, guys, it's saying 0.166666, so on and so forth. That is going to equal to x. So the first thing that I want to do is I want to move this decimal in, behind the number that repeats. Remember, the first rule is whatever number repeats, you want that to be the number right before the decimal. So I would have to multiply both sides by 100 in order to move it over 2 decimal places. So I'm going to have 100x is equal to 16.6 repeating. Remember, the 6 repeated, so you want that right before the decimal. Then the second equation is what you want is you want to have this decimal right before the number that repeats. So in order to do that, you're going to multiply both sides by 10. So this would give me 10x is equal to 1.6 repeating. So now when I solve this, when I subtract these two equations, it would look something like 90x x is equal to, these cancel out, 0.6 repeatings go away, and I'd be left with 15. So when I divide both sides by 90, I will have x equals, and then I just need to do reduce this. So you can reduce them by 5, and if you can see, they're both divisible by 15. So if I reduce the top and the bottom by 15, you'll get then 1 over 6. And if you plug 1 over 6 in your calculator, you get 1.6, excuse me, 0.1666666, so on and so forth, okay? All right, so does this pattern describe the problem number 7 that you saw? No, it does not. So before, we would have said, oh yeah, that would be 16 over 99, but obviously that wasn't the case. We got 1 over 6 as our final answer. So no, and the reason because the entire decimal does not repeat. Just the 6. Look at this cool guy right here. Okay, so let's go ahead now and look at this. Let's convert this now. Same idea, guys. Anytime you have a whole number, that's just going to be in front of our answer. So my solution, I'm going to have a 2 in front. And what I'm trying to do is figure out the fraction. So over here now in black, I'm only going to go ahead and look at the fraction part. So 0.015 repeating. So basically, guys, it's 0.015151515. So does the entire decimal repeat? Well, no, because you have the 0 hanging out here. So the first thing that you want to do, remember, is set this equal to x, and you're going to say the number that repeats, which is the 15, I want this decimal to move in front of it. So I need to multiply both sides by 10, 100, 1,000. So I'm going to have 1,000x is equal to 15.15, repeating. So next what I want to do is I want to do this a second time. So I'm going to have x equals 0.015, but I want to have this come right before the number that repeats. So to do that, I have to multiply by the decimal by 10. So then I'll have 10x is equal to 0.15 repeating. So then when I subtract these then, those cancel, and I'll be left with 990 equals x equals 15. So then what I'm going to do is divide both sides by 990. And then what I need to do is simplify this. So take out your calculators and see if 990 is divided by 15. And it is. I would get 1 over 66. Okay? All right, so just a few more. It says convert this decimal now. It's 0.0124 repeating. So it's like 44444, so on and so forth. So same idea. I'm going to set this equal to x. Second equation is what we want to do is move this decimal to the number after that repeats. So I have to move it over at 10, 100, 1,000, 10,000. So now we're getting a real big numbers. We've got 10,000x is equal to 124.4 repeating. And now the second one, when I look at the same number, I had 0.0124 repeating equals x. What you want to do is move this right before. So 10, 100, 1,000. So 1,000x is equal to 12.4. So now when I subtract these, I'm going to get, let's see, what would that be then? 10,000. So I've got 9,000x is equal to 124 minus 12 is 112. So then I just divide both sides by 9,000. And then I'm going to get x equals, so I don't even know what these are divisible by, but I know they're both even. So if I divide the top one by 2, I got 112 divided by 2, so give me 56 over 4500. Okay? And from there, I do not know, let's see, 45, 10, 56, so I'm just making a factor tree out really quickly. So we got 5 times 3 times 3 56. 7 times 2 times 2 times 2. Okay, so these are divisible, and you guys don't need to pay attention too much to what I'm doing, but it's divisible by 4. So if you did 56 divided by 4, you would get 14. So you guys would kind of just guess and check, start dividing these by 2, so on and so forth. So 56 divided by 2 is 14, and 4,500 divided by 4 is 1,125. Now, I'm not sure. I think you guys have this question in it, but if not, whatever number 12 was, you can change it to look like this, okay? All right, so now what we're going to do is the last two, we're going to combine these and then simplify. So my suggestion to you, instead of turning these into two fractions, is just add them up as they are. So this is 0.4 decimal that ends, and this is 0.444, so on and so forth, repeating. So when I add these up, I'm going to get 8 let's see, excuse me, take a step back, 0.8444, so on and so forth, repeating. So basically, how can I turn 0.84 repeating, with just the 4 repeating, into a fraction? You guys know this by setting it up to x equals 0.84 repeating, and then you can also get 10, what would that be, 100x equals 84.4 repeating, and 10x equals 8.4 repeating. And then you could have solved it this way previously, what we did. The other thing that you guys can do is you can look at this and you're like, hey, I already know how to write this as a fraction. It's just one fraction, so this would be 4 over 9. This one would be 4 over 10. Now, all I need to do is add these fractions by getting a common denominator, which is 90. So I'd multiply this one by 9, this one by 10. So this would give me 40 over 90 plus 36 over 90. So when I add these together, I'm going to get 76 over 90, and then just reduce them. So then when you reduce these, you can reduce them by 2, so get 45 on the denominator. And when I reduce the numerator, 40, 36, I think it's 36. No, 38, 38. 38. Okay, and that's it. Same idea here, guys. This one, what we would do is, if you look at this, 0.54, 54, 54, so on and so forth. And this one is plus 83333, so on and so forth. And if we were to add these up, I would get 1.37878878. So basically I'm saying, hey, can you guys convert 1.378 into a fraction? And we can. So the first thing that we would do is this 1 is just going to stay a 1. We don't even want to pay attention to that. Then I'm going to have x equals 0.378 with the 7/8 repeating. So first, I want this decimal to go after the number that repeats. So in order to move it 3 times, I would have to multiply both sides by 1,000. So then we're going to have 1,000. X is equal to 378.78. And then the next one, I want this number to come right before the number that repeats. That would be 10. So 10x equals 3.78 repeating. So then when I subtract these, I'm going to have 990x is equal to 375, and those get eliminated. So then I'm going to divide both sides by 990. And let's see, those are both divisible by, they're both divisible by 5. So I'm just going to go ahead and, I actually don't know what they're both divisible by. A bigger number than 5. So we're going to have this. I'm going to have 990 divided by 5 to get 198. From there, this would be then 3 times 5 times 5. And on the bottom, 198 is divisible by 2. 11 times 9. Okay, so just 3 times 3. Sorry, I'm just reducing these, figuring out what they're both divisible by. And I figured out you guys would just kind of use guess and check to see what they're divisible by. These are both divisible by 3. So if I did 75 divided by 3, I would get 25. And then if I did 198 divided by 3, I would get 66. Okay? This is as small as it can go. So that would be your final answer, okay? So guys, if you have any questions, don't forget, feel free to email me, ask your other teacher if they're watching this. Yeah, and I'll see you guys later.